Okay, that's great. So, if any of you have any doubts regarding the last two sessions, just to give a brief idea, in the first session we covered how blockchains essentially work and how the system of cryptographic hashes and encryptions work and how one block gets added after the another. Then we looked at how MetaMask as a wallet functions and what are test nets. So we got some Sepolia test ethers into our MetaMask wallet by using the Google Cloud faucet. After that, in the second session, we did a lot of Solidity. So we learned about what contracts are and a bunch of stuff regarding Solidity. So, any of those stuff you want me to go through again today? Anybody? Okay, so are we clear on basics of Ethereum virtual machine and Solidity? Just a quick show of hands, like how many people are comfortable with basic Solidity. We did try to do a calculator contract where we had different functions. We were taking in some values, we were outputting some values. So everybody is clear with that, how all that Solidity works. And anybody tried experimenting with Remix and all?
Yes.
Okay, no. Okay, you did actually. That's great. So what all did you try the calculator contract?
Mm, I didn't try calculator. I tried the person contract. That one I did.
Okay, you tried. You mind sharing it with us if you like, just for a quick thing?
Screen.
Yeah, yeah, just like what all you did and what all you figured out on your own, if you did some research and all.
Okay, fine.
Okay, yeah, that's great. So you tried to make this contract. It has a mapping as well. Okay, that's great. So you are clear with how mapping works and how it is from a key to a value and what are the different data types, right?
Yes.
Okay, and how to develop deploy it using Remix and all. Also, you're fine with that.
Yes, yes.
So I guess this should we should establish this as a base point in our today's session. So thank you for sharing, Sagarika. It's great work. So this we should establish this as our base point for today's session. So we should be comfortable with how Remix works. We should be comfortable writing basic code in Solidity, not pretty much advanced stuff that we would be covering in today. And apart from that, what we would be doing today is we would be seeing how Hardhat and ethers.js works. So to give you a basic intro, Hardhat is essentially uh, library in Node, so we can use that to set up projects in the Web3 world. So basically, we can set up our Ethereum projects using Hardhat. We can compile them. So in a similar way, like we are compiling our code on Remix IDE, we can use Hardhat to compile the code that we write on our local PCs. Because like when we are writing the front end as well as the contracts, we want our front end to interact with the contract. Like when you deploy on Remix, you get some buttons, right? You get an add button, you get a subtract button, for example, if you're deploying the calculator contract. So if we want a more advanced UI wherein the front end needs to talk to the back end, to the basically the chain that we have running, we use Hardhat. So Hardhat also helps us in running a local test blockchain. So it would be based on Ethereum only. So we would have different accounts which would be running in on a chain of which the sole validator is my local computer. So it would be running on localhost. I would get a RPC URL which I can add on MetaMask. So all this stuff we would try and go through today, so that tomorrow we can deploy our project actually on the Ethereum testnet. Today we will be deploying it locally using Hardhat, and tomorrow we would try and deploy it using Alchemy. So Alchemy is again a service provider from which you can get an RPC, and then we can use that to deploy it on either Sepolia or Goerli, both of which are testnets. So, getting started with today's session, we would also be discussing in tokens. So, tokens are basically, in a similar way, you get certain number of shares when you invest a certain amount in a company. In a similar way, tokens work on Ethereum. So, we have ERC20 and ERC721. So, let me first give you a brief idea of how our project would look like, so we have better picture of what we are working towards and what the final product will look like. So I'll just share my screen with you. Yeah. So this is like estate token, pretty basic UI. So we would be focusing more on how the blockchain part of this works. So this is basically a website where you can own fractional real estate. So in India also this is done. This is mainly done using REITs, or real estate investment trusts. So these are basically like mutual funds. So if we don't have that kind of high capital where we can afford to buy, let's say, a property full cash, or even after we are not getting a loan of that high amount, what we can do is we can pay, let's say, 10% of the property price or 20% of the property price, and we can own fractional ownership of that property. So let's say tomorrow that property is getting sold, whatever value of the property is at that time, I would get around 20% of that value if I am owning, let's say, 20%. So a similar thing can be done on blockchain. Why it is important is because on blockchain we can't back out of transactions. Like I told you in the first session, once any data gets deployed on the blockchain, we can't modify it. Once it is hashed, if we try and change any data, the hash of that block will change, which will invalidate that block and invalidate all future blocks of that as well. So that is the basic reason why we can't uh, tamper with any transactions that we do on the blockchain. And this project is basically on that as well. So if we go to my portfolio, it will show that there is a test apartment for which I have contributed 1 ether. I have 100% stake, and the shares that I have are 100 test. So test is basically a token, and tokens are like created using the ERC20 protocol. So just like we have Bitcoin improvement protocols, like I told in the first session, from which we can get the derivation path and the mnemonics. Similarly, there is a protocol for improving Ethereum as well. So in one of those protocol, ERC20 was like suggested as the standard way of creating new tokens on Ethereum. So this test is actually a token which can be created. So I have this account using my MetaMask wallet. So if I just show you, I have connected my MetaMask, and this imported account too is actually the account that contributed the 1 ether. So as you can see, I have 9999 ethers. That was because initially when the account was initiated, it had 10,000 ethers, and now it has contributed 1 ether to the uh, like list, the person who has listed this property. And here we can see operator is some other address. On the top right we can see the address of the current account. Here we can see the address of the operator. So if we somehow switch our MetaMask account to the operator account, we should get some more features, like, right? So let us try and switch it to the first account, which is actually the operator account. So we get a label of operator on the top right here next to our address. So this is our public address. This signifies that we are the operator of this particular test apartment. And as we can see, because it ends on 19th of April, the status is still showing as funding. If I just quickly change the date and time of my computer, Give me a minute, and we can actually see the status change. Otherwise, if I just wait until tomorrow patiently, that will also change. But just for demonstration purposes, let me just try and figure that out. Yes, so I just did that, and if I try and refresh, it will take some time to load because it is actually pulling in data from a local like chain that I have running on my laptop. I'll just show you how that works as well. Give me a minute. So now the status changed to owned because I changed the date of my local PC. It changed, and if we switch to the investor account, that will also show as owned, and my position, which is 100 test, because we divided this property into 1,000 equal fragments. And so basically, whoever has 10 tests will own 1% of the property. Are we clear till here? Just a quick thumbs up. Like, do we have a basic idea of what the project does and what it tries to solve? And this, if you research a bit about it, in Dubai as well, the government is trying to put the real estate ledgers onto blockchain just to prevent it from like tampering of data, and fractional ownership also is trying to be brought up as a new concept for people who want to explore different streams of income, like income from rental yield, and also if they own, let's say, 50% of the property, half of what the rent of that property is getting will be theirs. So this is what this project tries and solves. So herein we can see the stake is 100% because we have 1,000 tests. Let me just quickly switch to the owner account and show you how we list the properties as well. So here I can actually uh, like, let me just give a name like ABC flat, and these details can be given. So let's say my goal is to raise 10 ethers, and I set a deadline of 15 days. And token name, so yeah, token name is whatever names like Bitcoin, and the symbol is BTC. So I can create a take a token like ABC flat token, and I can give the symbol as ABC. And once I list this property, so I'll have to make a transaction using my owner account on MetaMask. So because I'm hosting this on the blockchain, I'll have to pay a network fee, as we discussed in the first session. I'll have to pay a certain amount of gas to process this transaction on the network. But since it is a local Ethereum blockchain running on my PC, I don't have to worry about this because it was funded with some 10,000 ethers. And now when I list that flat, I can see that one ABC flat is there, for which 48 days are left, and zero ethers are owned. So let me just try and quickly do this as well. Like if I change to this account, I can go in here and I can contribute. Let's say I contribute, the goal is 10 ethers and I contribute one. And I'll have to confirm this transaction over here. So right now, because it is still like in the ownership phase, it is not been completed, it is still in the funding stage. I can see one ether raised of 10 ethers, and once all the different people put in their money and we raise a combined of 10 ethers, those different owners will receive their fractional tokens. That's how the basic system of tokens work. And let's now try and understand tokens in a bit more detail. Just a minute, I'll be sharing the content. Just a minute. Yeah, can you guys see? So ERC-20 is the actual standard that was introduced. Like anybody who wants to create a new token should follow a set of rules. Why these set of rules were introduced is an interesting fact. Like because we have different wallets, right? We have Phantom, we have MetaMask, we have Backpack. So all these wallets, when they are trying to understand whatever tokens that we are creating, so there should be a standardized way in which we should name our variables, in which we should write the logic. So that wait a second, my screen just stopped getting shared. Are you guys able to see or is it lagging? No worries. So yeah, so why we have ERC-20 as a standard guideline is because we have different wallets, and because those wallets should be able to understand whatever code we are writing, it should understand the variables that we are using. That is the reason why we use these protocols. And Open Zeppelin is basically a set of vast set of contracts that have already been written by developers. So contract engineers already wrote those contracts. Wait a second, I don't know why my computer is lagging. I'll just rejoin the meeting, guys. Okay, just wait for 2 minutes. Yeah, I'm so sorry. I had some Wi-Fi issues with, I don't know, the screen share was failing. I was just getting logged out of the meeting. So yeah, continuing what we started. So we have ERC-20, which is a protocol of creating new tokens in a more standardized way, so that whatever wallets that we have, which are trying to understand our token, they don't face any difficulty. And whoever wants to create a new token, let's say tomorrow I want to create a new token, I can create it more easily. And Open Zeppelin, as I was telling, it is a library of a lot of contracts that were already written by intelligent like contract engineers, and they have been vetted, they have been audited properly to make sure that there is no error in those contracts. So whenever we are writing our own code, we can just use the contracts from like, Open Zeppelin. Let's say Open Zeppelin has a ERC-20 contract. Open Zeppelin has a ownable contract. Ownable contract, again, we saw in the second session when we were discussing Solidity. So it lets us manage who all are the owners and basically set up different modifiers and all. So let us go through these. So ERC, basically the custom tokens are any token that we might want to create tomorrow. Let's say tomorrow I can create a Raghu coin. Now, Raghu coin inherently doesn't have any value. Value is there in the Ethereum blockchain. So on top of that Ethereum blockchain, I can go tomorrow and say that tomorrow I am auctioning my services, so I can develop Web3 apps for different people, but I accept payment only in terms of Raghu coins. So that is the way I can create new tokens and try and create value for those tokens in a similar way like when we will be working on our project. So we would be using tokens for different properties. So each property would have their own token, and once 100% of those token will be distributed among different like people, that is when we will say that okay, now we have distributed all the property, so we can start finalizing the process. So those are actually what custom tokens are. Any token other than Ether on the Ethereum blockchain. So Ethereum blockchain has its own token as well. The one we know it as Ethereum only. So Ether or ETH is the native token of the Ethereum blockchain. But as I told you just now, that on top of this Ether, I can create a Raghu coin, which will also have all the properties of the Ethereum blockchain, but that is a different token and can be utilized for different set of purposes. So as I have put the screenshot over here, This is the Ethereum, that is the native ETH, and USDC, as we might have heard. USDC is a token that is pegged to the United States dollar. So whatever the value of USDC will be the same as the value of US dollars on the open market. So that is how these tokens work. So USDC, for example, is a custom token. And now, where are the native balances of these tokens stored? I mean, native balance as in the balance of Ether. Ether balance, as we discussed when we were discussing Ethereum virtual machines, is stored on externally owned accounts. And externally owned account will have a variable called as balance, where we will be storing the native balance. Let's say I have 5 ethers, that will be stored over here in EOA. Now, let's say tomorrow we have a custom token. Where will be the token balance stored? Any guesses from anyone? Like, token is a type of a contract. And if I'm trying to store something related to a contract, where should I try and store it? Any random guess, guys? Okay, so it would be stored in the storage hash. So storage hash has values of all our variables. It has, like, let's say tomorrow I have 5 variables in that contract. Whatever value will be of those 5 variables, that will be stored in the storage hash. And whatever code I have in my smart contract will be stored on the code hash. So that is how Ethereum virtual machine works. So my custom token balance would be stored in this storage hash over here. So every custom token on Ethereum is a new contract, and the protocol for creating those new contracts is ERC20. So here we can see USDC is a custom token. So we can go to etherscan.io and we can check how the contracts are written, and different tokens will have different contracts. Let me just try and screen share different tokens so you can see how. So yeah, here you can see that this is some random AMP token. So someone woke up and they just decided, I want to create a new token. That token will be called AMP, and this is the symbol of the token, which is also AMP. I mean, there are only 0.001% of the token is being held, so it is essentially a dead token. But if we move on to the contract over here, somewhere we can find ERC20. Mm, yeah. The interface IERC20. So this is actually the interface of the ERC20 standard as defined in Ethereum Improvement Protocol. So there was one Ethereum Improvement Protocol in which it was suggested that we should have this standardized way of, like, creating new tokens, and then it was, like, standardized, so anybody creating a new token should follow those set of things. We can create a token like that also, but following those standards, like, just makes it easier for wallets to understand it. So now, like, what exactly is a token? So token, it is a type of a currency. So we'll have to mine the token and issue the tokens to ourselves first. Let's say tomorrow I'm trying to create this AMP token. First, I'll create this AMP token and, let's say, issue a lakh of these AMP tokens to myself. So now the total supply of the AMP tokens is 1 lakh, and I have all the 1 lakh tokens of AMP. So tomorrow I can distribute those AMP tokens to different people, and then they can use. So it is basically like a currency. So we can mine them and we can burn them as well. So let's say tomorrow I say that I don't want this AMP to exist. I'll just, like, let go of AMP. So I can just burn all the tokens, which means they will not be used for any monetary value per se, they'll just be like burned to the ground and not be used again. So now let me switch back to my slides. So yeah, what should a token contract look like? So here we have, so like we have having a coin, we have some public supply, we have a owner, and we have a mapping. This mapping is again between address and UN. So unsigned integer is there. So the address will store the public address that we have, and uint will store the value or how much of that tokens do I have. So, and we have a mint2 function. So mint2 function, again, we have one address to, and we have an amount. So, and only the owner can call it. That's why we have a require message dot sender is equal to owner. So whatever the to address I have, let's say I want to mint some tokens to any one of you. So you'll send me your public key, which is your address, and I can mint, let's say, of the lakh tokens of Raghu coin I had, I can, let's say, give 1,000 Raghu coins to you. So similarly, transfer is between two accounts. So we don't need the owner to sign this transaction. Only while minting, we want that only the owner can mint, but transfer can happen between any two people. Like what happens in our centralized currencies, dirham can only be printed by the government, but when we are exchanging dirhams for goods, I can do it, you can do it, anybody in the world can trade dirhams, but we can't print new currency. So that's the difference between mint and transfer. And now we have a burn as well. So let's say I don't want the token to exist, I'll just use the burn method. So it is a good practice to have, like when we are creating new tokens, to have all these functions inbuilt. So full contract, let's say if we are making a contract for, say, our property token, I have a have it on my remix. Just give me some time, I'll share it. So yeah, here you can see in remix ID, I have a name, I have a symbol. So name is the name of the token, symbol is the symbol of that token. So like we created a token named ABC flat token. So that is the name of the token. Then the symbol was ABC. And okay, decimal. Again, this is very important. So let's say we have rupees, so or dirhams, let's say the maximum amount of fills I can have is 99, because 100 fills will give me 1 dirham. So for that decimal, for let's say AED is 2. Why 2? Because after the decimal place, I can have two digits at max. I can have 25 fills, 50 fills, 75 fills, 99 fills. But as soon as I have 100 fills, it will make a dirham. So similarly, for let's say our token, it is like, because Ethereum has up to 18 decimal places, it is a standardized way of like creating any new tokens. We just keep 18 decimal places for that. So that is the meaning of this decimal over here. And okay, token supply. So token supply is again an important thing. So we are trying to supply like mapping from an address to an unsigned integer. Unsigned integer again is the value, and address is any publicly available address of the token. So these are again events. So we learned about events in the solidity class. So when we are trying to check whether something has happened and like appropriately respond in our front end, or when we are deploying, we create these events. So these events listen for this. And escrow account, so why we need an escrow account in our properties contract is because let's say tomorrow uh, one property was listed, but the funding actually didn't get completed. So if I wasn't able to raise funding for 100% of the property value, what should happen is like whoever invested, they should get their money back, right? It shouldn't be like their money is stuck when the 100% property is not sold. So for that, we create an escrow. So if, let's say, we aren't able to list 100% of the property, whatever amount people would have invested would be returned to them in exchange for the token. So let's say they had 5 tokens, so they would get their ethers back, and we as the miner of that particular token will get our tokens back. So that is the way that it works. So this is if I am trying to create my token from scratch and using ERC20 as a standard. But as a allowances, we'll see in a minute on the slide, that would be easier to understand. But yeah, this is how we try and create new tokens. Mm, so that was a full contract. Now, yeah, if you go to this website, if you go to EIP20, we'll actually see a list of functions that every ERC20 contract token should have. So anybody writing a contract on the ERC20 standard should use these like uh, should use these values, should use the variable naming should be same, the function naming should be same. Let me just try and share the website with you. So all these, the documentation, so learning any new language or any new standardization, or let's say we are learning Ethereum, the best way to learn these things are using the documentation that they have. So similarly for Ethereum, if I just go to the link that I shared, this is the website that opens. So ERC20 standard, this is the token standard. So this was the person that suggested that okay, we should have a standard for creating new tokens. And here, as you can see, we have these methods. So name is a method, symbol is a method, decimals is a method, total supply is a method. So initially, like I showed you, the test flat, that I had a total supply of 1,000 test tokens. And because my other account was the sole owner of that flat, I had the entire 1,000 tokens with me. Let's say I had it with a 50-50 partnership with some other account. I would have 500 tokens and the other person would have 500 tokens, making the total supply again 1,000. So that is how this works. Just try and see the documentation. We will share the links with you so it is easier. And as I emphasized earlier as well, seeing the documentation is the best way to learn anything. So now allowances. One more important thing that we need to learn when we are learning about new tokens is allowances. So it is somewhat similar to, let's say, an add-on credit card. So let's say my dad has a credit card, but he trusts me enough to, let's say, give half of his credit limit to me using an add-on card. So if I go and let's say his limit is 10,000 dirhams, and if I have an add-on credit card of 50% of that limit, I would be able to spend up to 5,000 dirhams without taking any permission from him per se. So, like, he trusts me enough to let me spend 5,000 dirhams without like any regulations and all. So, that is how allowances work. So, let's say I have 200 tokens, and somebody else, Raman, has 300 tokens, and I allow Raman to spend 100 of my tokens. So what will happen is, let's say Raman wants to send 50 to Kirti, but it authorizes using my wallet. So that is how this thing works. And here we can see the full contract of any new. So this is the same of the property token contract that we created. And that's how it just works. So allowances basically similar, like somebody else can spend using my wallet. That is not the sole purpose of creating allowances. So basically, when we write contracts, sometimes we need to authorize the contract to execute some transactions on our behalf. So that is where these allowances come in handy. Oh, wait a minute. I'm not sharing the slides. So yeah, I have transfer from, I have transfer to. So these are basically different functions. So if I have an allowance, so I have a function called allow. So it allows the sender to spend certain amount, and again it emits an approval message using this event that we created for approval. So decimals we discussed. Now yeah, total supply is again total supply of whatever coin that we have in circulation. This is the balance of the specific address, and this transfer method is used for transferring from A to B. And allowance of an owner on spender, so basically let's say tomorrow I want to allow somebody to spend certain amount from my address, they can do that. Approve is allow a spender to spend some x amount, and this is basically to transfer like maybe. So burning logic. So again, if I want to burn the tokens, which means I just want to like not let the token exist only. So when that happens is I'm not exchanging it for anything of value. I'm just burning the tokens. It is important if let's say I want to stop the circulation of a token entirely. What I'll do is I'll burn my tokens, and so that logic, let's see. Okay. Yeah. So now when we are launching the token, just like we have IPOs in the stock market, we have initial coin offerings, we have different airdrops as well. So let's say tomorrow I can launch a airdrops and give you like 500 tokens just like that. So that's the thing about airdrops. And total vesting is, let's say I give you 500 tokens, but you get it in 5 years and 100 tokens each year. So that is how vesting and unlocking works. Now, yeah, implementation. So one of the most common implementation of the ERC20 is using Open Zeppelin. And Open Zeppelin is what we would be using again to write our contracts. So just give me a minute. I'll share this link so we can see. So I've put this link in the chat as well. And if we just open, it will open a GitHub repo. And that repo has the entire ERC20 standard implemented as it is. And as I told you, because these are written by very senior developers who we assume they won't make mistakes, and these are audited contracts as well. So let's say I have a balances which maps from an account to a integer. I have an allowance. So allowance, what it does is it has an account, but the mapping is to a account address of the spender. So let's say I am authorizing a spender. So that is why it has two mappings: one external mapping from account to a spender, and then the internal mapping, whatever amount the spender wants to spend. So this is the actual documentation of Open Zeppelin. So if you just go to this GitHub profile of Open Zeppelin and go to the repository, you can see all these token standards. So they have different standards as well. They have a 721. This is used for NFTs. So you might have heard NFT was a buzzword a few years back. Like everybody used those monkey faces you might have seen. So those are NFTs. So the standard for them is ERC 721. But for normal tokens, ERC20 is pretty the most popular thing that people use. So you can just try and go through this code base, see how this works. So we have a mint function. Okay, two important things. I think I have it in this slide as well. Yeah. Let me just switch back. Yeah. So this is just a screenshot from that GitHub repository. So here we have mint and burn. So mint and burn are basically implemented using the same update function. What this update function does is like it takes a from address, it takes a to address, and it takes a value. So it decreases the value of the from address, as you can see over here. The balance of from is decreased and the balance of to is increased. Now, what happens is when the from address is zero, like I'm just creating a new token, so I'm not taking it from anybody, I'm just creating a new token. So that is why we have from address as zero when we are minting. And if we are burning the tokens, the to address will be zero, which is over here. So like when we have over here, we are burning the coins, the to address would be zero. So, and this is how we can create any new tokens of our own. So like this is a my mintable token. So we are importing open zeppelin, and we are taking their erc20 contract, and we are just putting in our value. So that just makes our job easier. So whenever we are writing contracts, we don't have any worries that we'll probably write some wrong code, because once the contract is deployed on the blockchain, there is no way to change it or update it. So any doubts till now, like using open zeppelin and all? So we'll start coding the app now. Anything you might want to ask me till here? What are allowances? How do we import? Anybody? Okay, so now we'll actually start like coding the app. So, but before we do that, I just want you to like think what all methods should be there and what all contracts should be there. I gave you a basic demo of how it works, right? So anybody like of the things that you have seen, what all can be implemented using our uh, using what we have seen till now, ERC 720 and Solidity, what all you think we might have to do? Just try, take a wild guess by the time I will set up the project. So yeah. So I have like just created a folder, real estate final DApp. So this is my nomenclature, and now we would be starting with how to do everything. So let's just check. We are in this folder, real estate fin app. So I would request all of you to like start this alongside me so that we are on the same page, and like there's no confusion amongst us. So that is just a good practice to follow alongside. And now we'll
This is in remix.
No, this is just VS Code. So Remix was when we were trying to deploy it instantly. We just wanted to deploy and get some UI, some basic UI. That was when we were using Remix. We can write Solidity in Notepad as well. So here, because we will have both front end and the contract section, so we are using just VS Code.
This is an
So
online or in
no, this is the app of VS Code. So and try and keep it on your local machine because we will be running hard hat. So hard hat actually creates a blockchain on your local PC locally, and for that just it is a good practice to have VS Code installed. So all of you have VS Code installed, right? Or is there anybody who needs help with that as well? If you don't have, I'd say just follow what I'm doing for now, and once you have installed after the session, you can proceed. So for now, let's just start and create. So we have two main things. We'll have one front end, which is how the UI of our DApp looks and how different components will be there in the front end. And one section will be of the different contracts that we have to write. So what we'll do is we'll do mkdir to make new directories. One will be the contracts and one will be the front end. So just do this. It will create two folders, two empty folders, a contracts folder and a front end folder. Now we'll go to the contracts folder and we'll just initialize npm. So npm again is node package manager. So we should have node. So now we are, when we are in this contracts folder, what we try and do is we just try to initialize npm and run this. So yeah, the code for initializing npm is npm init dash y. So what this does is this creates a package.json. So it just has a name like, okay, contracts is the name. The main file will be index.js, and it just initializes our contracts with the npm. Now what we'll do is we'll do npm install. Yeah, we'll run this. So uh, this will install hard hat onto our PC. So in this project it will install hard hat, and while it's doing, like, what hard hat does is, as I told you, like, it helps us to compile the EVM bytecode, and it helps us with testing and all as well. So when we are writing different contracts, we need to test them. Again, why? Because once we deploy it on the main Ethereum mainnet blockchain, we can't do any changes. So it is essentially a good idea to mm, like just test your contracts before deploying them. So it will once we have hard hat installed, so it will just help us with all that. So it will help us with, like, it will keep solidity stack traces. So like if a transaction ever gets reversed, hard hat will give us a notification and all of that. So like now that we have hard hat installed, the next command that we run is npm npm hard hat init. So this will just initialize the, sorry, I missed a D. Yeah. Now it asks me, what do you want to do? So I'll just create a JavaScript project, and the root is the same folder that I am in. And we want a git ignore because when we would be adding APIs, that is when we require the git ignore. And sample project dependencies, just do yes. So now it will just take some time and install all the relevant dependencies for us. So as you can see, the packet.json gets updated each time that we have a new dependency. So when we installed hard hat, this got added under dev dependencies. Why it is added under dev dependencies again is one second. Because we did this command save dev, so it saves it under dev dependencies. Any other dependencies that we install will be stored here in package.json only, but it will be saved like with in dependencies only, not dev dependencies. So one more dev dependency is this now foundation tool. I think it is run. Yeah. So now we can move forward. Now we need to install two more things. So we need to install Open Zeppelin because Open Zeppelin is one the place where we will be getting our contracts from, and we also want one .env. So whatever environment variables that we have that are stored in env file, and we are able to use them in our code. Like these are just pretty standard stuff like .env. If we have done Web2 programming as well, like just simple front end and back end stuff, you might know. So that installs Open Zeppelin and .env as well for me. So now I have all the dependencies with me. Now I'll start and writing the contract. So whatever contracts that we write will be in this contracts folder. Now when I install Hardhat, it gives me a like standard log.sol contract. We don't need this contract, so just go ahead and delete this for now. Go to trash. Ignition also it will create. We don't need that for now. And here in test is where we would be writing all the different test cases. So if you just look at the syntax, yeah, it. Whenever this it statement starts, it is one test case. So this is one test case. This is another test case. So this is how we write test cases. We would be coming to this as well. So our project basically has three contracts. One contract is the project token contract. Project token contract is like the one which actually creates a new token for different properties. Then we have a property escrow contract which makes sure that we have an escrow account. So God forbid if some property is not like sold fully, we would just keep it in the escrow account. And property factory is the last contract. This just implements the property escrow. So let us start writing it. I'll try and code it live as much as possible, but like if time doesn't permit, I'll just send you the codes using GitHub. So that would be posted after the session on the WhatsApp group, so you can have a look at the contracts and the test cases yourself as well. So I'll just go to the contracts. I'll create a new file, and the first file, as I told, was property token.sol. So yeah, this is just my first contract. So are you guys with me over here? Anybody has installed Hard Hat and like have their dependencies set up? Anyone? Or if you are like having some issues also, you can tell. We can probably guide you alongside as well. Okay, no worries. If you try installing and if you face any issues anytime, you can just put it on the WhatsApp group. I hope everyone is in there. So we'll just have a look at that, and whatever is the issue, we might try and resolve it. So let us start writing this property token.sol contract. So anybody wants to take the lead and tell me what's the first line of whatever contracts that we write? Anyone? Okay, so it is the license identifier and our Solidity version, right? So I'll just copy paste that. So this is our license, the MIT license, and this is Pragma Solidity. So any version above 8.20, but not a 0.9. That is what this means. Now we'll do import, and import is where we'll be adding Open Zeppelin. So add @open Zeppelin slash contracts. Now see, there are so many contracts in Open Zeppelin, and I'm all seeing all those, but the one that we need is the tokens one. So we'll do it slash token, and we should see, yeah, ERC20 slash ERC20 dot sol. That is the one we want to like import. Now, when we are done doing that, we actually start writing our contract. So contract property token is ERC20. Now, is keyword, if you guys remember again, it is the keyword for extending a contract. So whatever contract is written here in ERC20.sol is the one that I'm like uh, extending over here. Address. So this, what it does is it creates an escrow account. So as I told you, if let's say we are unable to sell a property fully, we would be using the escrow account to just give everybody whatever amount they invested back. Now we'll have another line. So we'll, whatever tokens that we mint, that should be closed like once the minting is done. Let's say my initial goal was to mint 1 lakh tokens. So once that is achieved, I should close the minting. So that is when we use public. So Boolean is basically because it can only have a true false value. In the above line, we have address as the data type because again, the escrow will be an account. And in order to identify an account in Solidity, we use the address data type. So that is why we have address over here. We'll just create a variable called minting closed. That is just to signify whether like it is closed or not. So for this only we'll create an event also. So event minting closed. That will just raise a request like, okay, the minting has now been closed. So that is the purpose for this event. And now we'll have a modifier. Now, as you guys might know, modifier, why is modifier used? Modifier is used when we want to grant access to certain accounts only. So instead of putting the like require line again and again, require message dot sender is equal to escrow, what I can do is I can put that require line within a modifier. So if I name this modifier only escrow, so that will just create a modifier. So here I can put my main logic, which is require message dot sender to be same as escrow. And we can put in a message here as well. So the message that we might want to display is only escrow can mint. Escrow basically is the owner in this case. So the creation of the tokens would be done by escrow. That is why we are printing this message over here that only escrow can mint. And another important thing, whenever we are ending a modifier, that should end with underscore. So this completes our modifier. Now, now the next main important thing once we have the modifier is the constructor. So let us just try and do that. Constructor. What all we have string, memory. So whenever we are using, as I told you in the Solidity session, we need to put memory whenever we have string because string is stored in heaps. I mean, in the storage for, let's say, solidity. But all these addresses and unsigned integers and boolean values would be stored on a stack. So because we are using the memory and not the stack, we need to put in that keyword, and we put in e. So this underscore before variables in constructor is a standard practice that is used to make our code like friendly for other people to understand as well. So it is just a good practice to put an underscore when we are like defining them in constructors. Another thing we have is the symbol. So this constructor is actually like, it will initialize the token. So it has the name, it has the symbol. Now it will have an address, and the address should be that of the escrow. So that is why we'll put escrow over here, and that finishes our constructor. But okay, sorry, yeah. Now what we need is, we need to create a token. And how will we create the token? We'll create the token using ERC20. So when we write ERC20, we'll just initialize it. So here it tells us, what do we need? We need a name and we need a symbol. So what is our name? Our name is underscore name. What is our symbol? Our symbol is underscore symbol. We can only use this once we have like initialized our constructor. So that is why that was a necessary step. Now we'll write. Uh, we need to like initialize the escrow variable as well. So for that, what we do is require. Now escrow can't be a zero address, right? Because even though they can mint, but their address should be some actual Ethereum public address. It can't be zero. For that reason, we add this line, underscore escrow is not equal to address bracket 0. So address bracket 0 is just a way of writing that the address can't be all zeros. We could have also written it something like 0x00000. So that is another way of writing it, but a more standardized way of writing it is just address bracket 0. Now we can add a comment here as well, like just to make our code more readable. Escrow address can't be 0. So like if this require condition fails, this will be the message that will be printed. If this require condition fails, this will be the message that would be printed. That is how this require statement works. And now then we'll just initialize the escrow variable to whatever value that we have, and the value that we have is underscore escrow, and the standard variable is escrow. So we just initialize that, and that is done. Now we'll have different two different functions basically, one mint function and one close minting function. So like uh, mint so we'll when we want to create new tokens, so that is when we'll call the mint function. And let's say I buy 1 ether worth of tokens. So as we saw earlier, 1 ether gave us 1,000 tokens. So whenever I receive a request of 1 ether, I should mint 1,000 tokens and give it to the person who gave me 1 ether. That's how this works. So we'll have a mint function and we'll have a close minting function. When will the close minting function be called? The close minting function will be called like, let's say uh, all the property has been sold, 100% has been sold. So then we'll invoke this close minting function so that like no new tokens can be created. So let us just quickly write the logic for that. So function mint. Now mint, what all parameters should it have? it should have one address, and that address one will be the to address, and it will have the amount. So whatever amount of tokens that I need to send, that will be a unsigned integer, and that will be our amount. So these are the like two main parameters. And one thing that we need to like do over here is external only escrow. Why this is important is that only escrow is because we created this modifier over here, right? Only escrow modifier. So we want that only the escrow can call this function. And external is just a good keyword to use because it is more gas efficient. So in the second session, when we learned about what gas is and how the Ethereum virtual machine works, in that session I told you like external is just a keyword to like minimize our gas expenditure. So it just makes our contract more like, in a way we can say, uh, more efficient, so less gas is used. Now in this we can just call underscore mint. So when I call this underscore mint and I pass the values to and the value amount, the logic for this mint will be written in a different contract. We'll come to that in a second. But here, what we want to do is whenever that mint logic is called, we need to send an address, some tokens. So that is what we are writing over here. And yeah, any thing you feel is uncanny over here or something that you might think can be improved, there is one logic that I have intentionally not written right now. Anybody can guess? I told you there are two functions, one mint function and one close minting function. So should I put in any logic before my mint, before I call my mint function, within that only? Anybody would like to take a guess? Okay, let me first write the logic for the close minting function. Maybe then it will make it like easier to grasp. So function close minting. So again, I'm trying to name all my functions in camel case. So camel case is the standard no, like variable nomenclature that we use in object-oriented programming languages. So again, we use external and we use only escrow because close minting can also only be done by the escrow account. So I do this, and what will I try and do here? Anybody? What logic should be there in the minting close minting function? Keep in mind that I have a boolean called minting closed and I have an event called minting closed. So what should I write within this close minting function? Anybody, please just raise your hand, take a wild guess. I have a boolean variable called minting closed, and I have a function close minting which should occur when minting is closed. So what should I do? Okay, no worries. So what we'll do over here is that we'll keep take this minting closed variable and we'll set it to true. Why? Because till the time it was false, I I can mint new tokens. But once it is set to true, I basically can't mint new tokens. So that is my essential logic for the close minting functions. And what we do about the event is that we emit the event. So what event do we emit? We emit the. So right now, what it was showing in the yellow thing also, like the red underline. Wait a second. Yeah, this is because yeah, identifier already declared is one, but because we are not calling it, once we call it, that should disappear. So emit we do. Okay, maybe because we have our like uh, boolean variable also set as minting closed and this also set as minting closed. Let me just do one thing. Let me make this m capital. Yeah. Okay, good. So that is all the logic that we have over here in this contract. So what this contract does is it takes an address of the escrow account, it takes a boolean variable minting closed, it emits an event also minting closed, which is called when this variable is set to true. And here is the close minting logic. Now, one thing that I wanted you guys to figure out was like whenever I'm minting, there should be one line over here which is require require minting closed. What do I mean by that? This that the minting closed boolean variable that I have, it should be false, right? Only then should I call the mint function. So that is my required logic over there. So only if this is set to true, then if minting close is true, I shouldn't be able to mint new tokens, right? That is why I add an exclamation mark before that variable. So till the time that variable is set to false, I'll be able to mint new tokens. Any issues with this contract? Anyone? So let me keep it for 2 minutes. Just try and go through all the lines of this contract. If you have any doubts, just feel free to ask. Okay, is everybody clear with this contract? Just give a thumbs up if you are, so we can move forward. Anyone? Okay, no worries. Let's start like coding our next contract. That is the property escrow contract. Property escrow dot SOL. Now again, we have our boilerplate that we have to specify the license and we have to give a version of Solidity. I'll just copy paste that. Now, one thing that we want to import over here is the contract that we just wrote because like that will come in handy later. So I'll just import this property token dot sol. Yeah. Now we need to write the contract for this particular file. So I'll write contract property escrow. Now, in this, we need to first define one constant that will be how many tokens do I want to give for each Ethereum. Like I showed you in the beginning, like when I shared the project, that for one Ethereum, I was getting 1,000 tokens of my 1,000 test tokens. So that is like, let's keep it that way only. So for every Ethereum that we have, we'll give away 1,000 tokens. So let me write the logic for that. So I'll create an unsigned integer. So this again, this variable, all it does is it defines a public variable. So again, as we learned in the solidity session, this will be visible to all the contracts, and it is a constant, meaning the value of this tokens per ETH can't be changed anytime further. So whatever tokens that we would be creating, they would be like and they would just be using this same thing. So for every Ethereum that we get, we would be giving away 1,000 tokens of any flat. So let's say tomorrow I list a ABC flat. So for one Ethereum, they will get 1,000 ABC tokens. If I create a DEF flat, so for one Ether, they will get 1,000 DEF tokens. Is that fine? So yeah, just a second. So now let us move on. So we have quite a bit of variables in this one. So after this, what we have is the operator. So whenever we are creating a operator is the one that creates new listings. So if I need to make any new listing on the website, I need to be signed in with my operator account. That is why I'm creating a operator with like type address. And now another variable that we have is goal. So goal basically is how much ethers do we want to raise for that particular flat. So again, that will be an unsigned integer. And we'll change it to goal. What else do I need to add? I need to add a deadline. Now, deadline again will be uh, unsigned integer only because we convert the date into a integer timestamp, and that's what we use. So again, the same, but the variable name would be deadline. Now, okay, we had a section for like pictures as well. So if we want to put any other URLs or any other data along with that, so for that it is just a good practice to have a variable for that as well. So string public metadata, this is any other data that we might want to give along with that listing, and one will be the title. So string public title. Everybody fine till here? Like you have understood what all different variables we have? Okay. So now we actually create the property token. So property token again is like it will be imported from this file. So property token dot soul. So we create that. So we create a property token and public, and we name it property token. So this is like if you look at it from Java perspective, this is your class and this is the object of that class. So that is how this works. Now again, we need some more variables. We need the total raised amount. So how much of the goal have we actually raised? So that will be again a variable that we have. And what is this finalized? As I had shown you in the in the website. So whenever the deadline crosses, I can finalize that. Okay, I have got 100% of the goal as the raised amount, and I'm ready to give proportional tokens to whoever has invested or whatever those addresses are. So once I do that, this finalized will be set to true. And so whenever this becomes true, that is when we know that the operator has withdrawn. So now operator doesn't hold any tokens, but the actual investors and the addresses who have made those investments actually get those tokens. Now to track who has made how much contribution, what percentage of ethers has come from which address, what will we create? Anybody? We have seen it in quite a few like places till now. Anybody wants to guess? Okay, so we'll create a mapping, right? We'll create a mapping between, one second. We'll create a mapping, and that mapping will be from an address data type to a unsigned integer. Why? Because we want to know which address has contributed how much. So this will what our mapping will look like, and we'll just name it contributions. Now we'll create a few events. Now, because of lack of time, I'll just copy paste the code over here and explain it to you. Okay. So one contributions made. So whenever a new contribution is made, this event will be called. And once we turn the this boolean variable finalized to true, that is when this event will be called. And shares claimed. Okay. So if we raised 100% of the amount, then we will call this shares claimed event. And let's say we were not able to raise 100% of the amount, that is when we'll call this refund issued event. So again, let me just try and give. So when transaction executed or when 100% amount not raised. So that is how these two function like events work. Now we'll actually go ahead and initialize a constructor. So now all our events, all our mappings, and all our variables are there. So the next obvious step would be to initialize the constructor. We'll write constructor, and what all do we have? Again, okay, so as you might know, because we are uh, initializing all the variables that we have written earlier as well. So I'll just copy and paste it over here because it is quite a lot of lines of code. So yeah, here we are putting the value of address in operator in this variable. Here we are putting the value of goal in this variable, the value of duration. Uh, okay, yeah, I forgot to write one variable. Okay, no, so sorry. So this duration is actually a funding window, and it will be calculated as and when, using this deadline. So EVM, the Ethereum virtual machine, has a date and time of its own, and when we call the that whatever date and time of the Ethereum virtual machine and whatever deadline we have, that will give us the duration that we have pending basically. And then we have, obviously we have the title, we have the metadata, we have the token name, and we have the token symbol. This token name and token symbol and this title, this we have to initialize because we are using this property token, uh, like this object we are using. That is why we have to initialize these three values: title, token name, and token symbol. Now that finishes our constructor. Now when we actually start writing the lines, first we need to like give some we can give some required statements in the constructor only. So we need not create a new modifier. Why? Because whatever we put in over there, that will be true for all the functions that we write in this contract. See, here when we had this modifier is being called on this function and this function. So here also we could have like initialize this in the constructor only. But let's say if we have some functions where we don't want the modifier and some functions where we want the modifier, that is a place where using modifiers is beneficial. But let's say if I have something which should be true for all the functions, that is where I can put it directly in the constructor code. So yeah, here are those lines. So operator address cannot be zero, obviously. Goal should be positive, yes. Duration should be positive. I can't create a new property listing with a date in the history. And obviously, like the title length should be greater than zero, because without a title, how will we list any property? And here again, we are like, this was passing the values in the constructor, and here is where we are actually defining whatever the variables that we have. So we have this operator, we are equating it to operator, not equating it, just assigning the values here. And what now left is the creation of the property token. So similar to what we do in Java, sorry property token is equal to new property token, and the values that we gave over here. See, what does it want? It wants a name and it wants a symbol. So what is our name? Our name is the token name, so we do token name. And what else we do is we do the token symbol. So, and what we can do is we can also pass an address over here. So let me just tell you how that works. So yeah, so here I can pass an address. Any idea what this over here is? Like this keyword. Okay, it actually gives us the address of the escrow. So since that was there in this property token dot sol, the escrow that we have, and because of that, so here when we are calling this, it will take like this import, and it will give us the address of the escrow account that we have created. That is why we are passing it over here. uh, why we need to pass this like address basically is because only here, if I show you, only the escrow can mint new tokens, right? Because of this, when I am creating the property token over there, I am also passing one address which is of type escrow. I mean, sorry, I am passing an escrow variable which is of type address. Till here everything clear? So this actually completes our constructor over here. And now let me just quickly tell you the different functions that we have so that at least two of our contracts is done, and remaining we can do it in like tomorrow's session. So yeah, this is okay. This is the contribute function. Yeah. So how this contribute function works is, so again, the timestamp should be less than the deadline. Why? Because we can only contribute if it is an open property listing. If the deadline has already passed, we cannot contribute. Now, okay, the value should be greater than zero, as in whatever contribution I'm making, it can't be negative. And operator cannot contribute to their own property listing. That is why this statement is there. And it shouldn't be finalized already because we have this boolean finalized in the previous one, right? No, sorry, in this only we have, yeah, boolean public finalized. So that finalized should be false, because if it is already finalized, again I shouldn't be able to like contribute to any listing. Now what these two lines do is, it calls the contribution, and message dot sender as in whatever owner like whatever mm, contribution I have, that will be added. Why added over here? Because I'm contributing, so it gets an entry gets added in this mapping. And what that entry is, that entry has my address and whatever value that I have. And again, the total raised variable gets incremented by whatever value that I contribute. And I'm emitting a event also, this contribution made event. So this will, like, this has the address which has made the contribution and the amount of the contribution over here. So that is how this contribute like works. And here if you notice, this payable keyword is actually a very important keyword. So like, this is a keyword which basically tells us that uh, this is a method which will have ethereums being sent or ethereums being given. So because our token is based on the ethereum blockchain, so if we mark a function as payable, there should be some ethereum along with it. That is the payable function. Next, what we have is, we have the finalize function. So here we have like message dot finalize method function can only be done by the operator. Let's say tomorrow I am just an investor, I shouldn't be able to go to, let's say, a property and mark it as finalized, because if I get the power to do that, I might abuse that power and mark any and all properties as finalized, so that will just defeat the purpose. So that is why we have like message dot sender should be the operator, and timestamp should be like greater than the deadline. Why? Because obviously if the deadline is still pending, let's say deadline is for 25th of April, I can't mark it finalized on 18th of April. That is why this condition is there. And the total raised should be greater than or equal to the goal, because if the goal is not met, again I can't mark it as finalized, and it shouldn't already be set as finalized. Now you might wonder why we are not using modifiers over here. That is because each different function has a different set of require statements. Now, if we would have found out a common set of require statements, we could have implemented. But if you see over here, here we have message dot sender is not the operator. Here we have message dot sender should be the operator. Now, because of that, like we can't we can't create a common set of modifiers, and we'll have to write require statements for each and every like function that we make. Now we will do the claim shares function. So what the claim shares function does is it basically allows you to claim whatever tokens that you have. So it shouldn't be finalized, and contributed is the contribution made by the sender. So whatever account I have, I'll check the value. So when I go to this contributions mapping and message dot sender gives me the address. So I put in the address. What do I get? I get the amount. I get the amount that that particular address has contributed, and I store that in a variable called contributed, and that will come handy later on. So uh, and once that is there, we just make the contributions equal to 0. Why? Because now we are minting new tokens. This tokens to mint variable tells my mint method how many tokens should I mint, and that is whatever contributed amount I have in ethers multiplied by the tokens per ETH. What was the tokens per ETH? It was 1000, right? It was created somewhere in, yeah, only on the top. Yeah, tokens per ETH is equal to 1000. So let us say I contribute 1 ether, it should mint 1000 new tokens. And where will when are we calling that mint method? That is being called over here. So property token dot mint, it will go to this contract and it will call the mint function. And then message dot sender, again the address who is trying to claim the shares will call this function. So whenever message dot sender clicks over here, it will give tokens to mint, and tokens to mint is basically the value that I have, how many tokens should I mint. And just two more functions, and then we would be done for the day. Next is, now obviously if we are claiming shares, there might be a possibility that uh, like we have to claim a refund. So in that case, we have this claim refund method. Again, all these are external because there should these are being called by some other contract and not our current contract. That is why we are using the keyword external, and this is what makes it like efficient code. So we are not unnecessarily trying to run this from this current Solidity contract. And again, these are a set of required statements. Goal was met, no refunds, and this contributed should be like greater than 0, because if that is not there. Contributed is the like what we initialized over here. So that is the value of whatever they have contributed. Yeah, contributed is contributions of that particular address. So if contributed is equal to 0, then obviously I don't have anything to return. So that is what this required statement is doing over here. And obviously, so then once we have refunded, again we make the contributions by that particular user 0. If we don't do this, there is a possibility that a sender can come and claim refunded twice or infinite number of times, because every time this required statement will be executed, this will show the value. So it is extremely important to update this value to 0 once we have made the refund. So after that, we like just call boolean success, and like we just print away like if the success happens, uh, as in like if success is set to uh, like if success is there, success meaning that the shares have been claimed. So if success is there, we print refund failed. Otherwise, we issue the refund, and then we call this we call this event. I mean, we emit the event that okay, the refund has been issued. Now, okay. Now we create a summary event. So that will be just a set of values that the function is returning. Let me first copy and paste that function and then tell you what it does. So if you see here, it is basically like okay, it is an external and it is a view only event, a view only function. We discussed this again in the solidity session that we had, that view only functions are those functions which cannot change any data on the blockchain. They can only view whatever data is already present on the blockchain. So in this case, whatever local chain that we have, they'll just be able to view. So what all can they view? They can view the operator, they can view the address, they can view the title, they can view the metadata, they can view the goal. So all this they'll be able to view, and they'll be able to return. So this basically, the summary function is a like clean way of uh, getting the values for our front end, because in tomorrow's session when we would code the front end, actually it is better to have only one function where from which we get all the values, rather than us calling a different function for each new value that we want to get. So by creating a function like this, we can get the operator and the deadline from the same get summary function. We don't have to call new functions each time we want a different variable. So that is the purpose of this one. And now just one small line of a new function, that is the claimable shares. So yeah, this is the claimable shares function. Again, what this does is uh, obviously it shouldn't be finalized, and if it is not finalized, what we do is we allow the investor to claim tokens per ETH. So again, it returns a integer value, and what that integer value is, whatever contribution they have made times the tokens per Ethereum. Again, this tells us the number of shares that we have to mint, and this also tells us how many claimable shares do they have. So that is it for this uh, solidity contract. And so we have covered two contracts. There is one more contract, which is the property factory contract, which we would be doing in the next session since we are out of time. My initial plan was to cover that today only, but it's fine. We'll do that tomorrow. And after that, we would see how the front end interacts with the back end using again Ether's JS library, and we would be finally deploying that project in a way that you can run them on your local machines and as well as push them onto GitHub. So that is it for this session, everyone. If you have any doubts, you can ask me right now, or you can also post them on the WhatsApp group. And see you all tomorrow, and we'll finish the project tomorrow. Any doubts, anyone, like anybody wants to ask anything? If not, you can leave.